Good day, everyone. Today we're going to tackle about the finite geometric series. First, we're going to discuss about finite geometric series. When we say finite, it is a kind of sequence that has an end term. There are four conditions that we could consider in answering or in solving problems about finite geometric series. First condition is if r is not equal to 1. If r is not equal to 1, then we're going to use this formula. S sub n is equal to a sub 1 multiplied by r raised to n minus 1 over r minus 1. Next condition, if r is equal to 1. If the common ratio is equal to 1, then we will use the formula a sub 1 times n, or a sub 1 or the first term multiplied by the number of terms. Next is if r is equal to negative 1 and it has an even number of terms. So we'll just use this formula because S sub n or the sum of this series is equal to 0. Last, if r is equal to negative 1 and we have an odd number of terms. So the answer will be S sub n is equal to a sub 1. Using this formula, we can say that a sub 1 is our first term, n is the number of terms, r is the common difference, and S sub n is the sum of the geometric sequence. Now let's try to give an example on each kind of condition. First is find the sum of the first 20 terms of the sequence 10, 10, 10, 10. This is considered geometric sequence with a ratio of 1. So since it has the same number of terms, the same value of terms, we could just do is to add the number of is to multiply the number of terms to the first term or any of other terms. So in this case, 20 times 10 is equal to 200. So this is an example for r that is equal to 1. Let's go with this example. In this case, if we're going to solve for the common ratio, we can get the value of negative 1 as a common ratio. Another indication of that is it has the same numbers but has an alternating sign. Now I want you to look at the the number of terms that we need to find. The sum of the first 41 terms. 41 is an odd number. So if we solve this, we just use the value of a sub 1. Why is that? Because if there are 41 terms that has is the same number with alternating sign, 40 terms could cancel out each other and only one terms will be left. So that is a sub 1, which in this case the answer is 15. On the next example, find the sum of the first 50 terms of negative 12, 12, negative 12, 12, and so on. So we can say that the common ratio is negative 1. Now, since the number of terms is equal to 50, an even number, this will cancel out all the numbers. Therefore, we can get a value of 0 for the sum of the first 50 terms. This should be next. Last example for another condition. Find the sum of the first 7 terms of the sequence 16, 32, 64. We're going to get the common ratio. We can solve that the common ratio is equal to 2. This is not equal to 1, so therefore we will use this formula. S sub n is equal to a sub 1 multiply by quantity r raised to n minus 1 all over r minus 1. So all we have to do is to get the given, which are a sub 1, r, and n, which in this case, our a sub 1 is 16. So you can see in the problem, our n is 7 because we are asked to find the sum of the first 7 terms, and our r is 2, or the common ratio is 2. Now it's to find a sub n. Using this formula, we just substitute the values that we have and are given. And after we substitute the value, let's just evaluate it and can we can get the answer of 2032. Now, here are some of the examples that we need to tackle in order for us to comprehend more about geometric series. First of this is, what is the sum of the first eight term of the geometric sequence? This is an easy type of problem. So all we need to do is to carefully find the given in order for us to answer this problem. Again, we will use this formula. So therefore, we need to find the given a sub 1, the first term, the common ratio, and the value of n, or the number of terms. We can compute first for the common ratio, which is 2. And we can see in the problem that we have 3 as our a sub 1, or our first term, and 8 as our number of terms, and 2 for our r. Let's copy the formula first, substitute all the values that we have, evaluate the equation, and solve for the value of a sub 8. That is 765. Now, I can teach you on how to use calculators in answering this. We need to know first how to evaluate this manually. So 2 raised to 8 is equal to 256 minus 1 times 3. That is 765. Example number 2. What is the sum of the positive integral power of 3 between 1 and 800? We need to learn more about the terminologies in mathematics in order for us to really comprehend this. Now, the meaning of positive integral powers of 3 is that 3 raised to all positive integers number that would correspond to the values between 1 to 800. That is a raised 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, and so forth. If we're going to compute the first several values of 3 raised to the integral positive integral power, we will get the following answer. Now all we have to do is to consider all the product or all the answer that are between 1 to 800, and that is 3, 9, 27, 81, 243, and 729, because 3 raised to 7 will fall out greater than 800. So now we have 3, 9, 27, 81, 243, 729 as our sequence. Now you could just simply add this, and get the sum of the first positive integral power of 3 between 1 and 800. But for the purpose of this discussion, we will just use the formula to answer this. So our given for this is 3 as our first term, n as our second term, or n as our number of terms because we just considered the first 6 terms, and r as our common ratio. Let's substitute that to the formula. 3 raised to 6 is 729, and 3 minus 1 is 2. Then 729 minus 1 multiplied by 3 divided by 2 is 1,900. 1,092. So this will be our final answer. Now, in example number 3, find the sum of the first 10 terms of the sequence 1, 5, 25, 125, and so on. There's different variety of problem wherein it was written in this kind of form, just to indicate that this is a series. Now we could easily enumerate the given, which is 1 for a sub 1, or the first term. We have 10 for the number of terms, and we have 5 for r. Again, you just divide the second term by the first term, and the third term by the second term, and you'll get 5. And let's find the sum of the first 10 terms. In this case, n is equal to 10. Therefore, we are dealing with a large amount of numbers, and 5 will be our base. So 5 raised to 10 is equal to 9,700,000 65,625 minus 1 all over 5 minus 1, which is 4. Now, all we have to do is to minus it and divide it by 4. Then we get the answer of 2,441,406. Example number 4. In this kind of example, the formula for a geometric sequence is given. So now we need to find here the common ratio, the a sub 1, first term, and the n is given already. So I will read the question. In a sub n is equal to negative 7 raised to n minus 1, what is the sum of the first 7 terms of the sequence? Now let's consider first writing the formula. To get a sub 1, you have two methods on doing this. First is you just substitute 1 to n, and we'll get, sorry, a sub 1 is equal to negative 7 raised to 1 minus 1. As you can see, I'll just substitute 1 on n because we're trying to get the first term. So that is a sub 1 is equal to negative 7 raised to 0. Then any number raised to 0 is equal to 1. So therefore, our first term is 1. Now, for the common ratio, you just get a sub 2. A sub 2 is equal to negative 7 raised to 2 minus 1 equal to negative 7 raised to 1, or a sub 2 is equal to negative 7. Now you have a sub 1, that is 1, and a sub 2, that is negative 7. So all you need to do is to get the ratio between these two numbers, that is negative 7 over 1, and you'll get negative 7 as your common ratio. Or you could just compare the formula, and you could easily see that our common ratio is negative 7, and we have a invisible number here, which is 1, for our a sub 1. And having that in mind, we will already have a given a sub 1 is 1, n is 7 because it is written in the problem, r is equal to negative 7, and we should solve for a sub 7. So all you need to do is to plug in all the givens that we have. Negative 7 raised to 7 would be times 1 would be negative 823,543 minus 1 divided by 8. So we have 102,943 as our final answer. So the sum of the first 7 terms of this geometric sequence is 102,940. Now let's go to example number 5. Let's just solve this. Quantity x minus 1, x, and quantity x plus 2 are the first three terms of a geometric sequence. What is the sum of the first six terms? Again, we try to understand the problem. We can say that Rn is 6. Now we need using this variable, using this given, we need to solve for x in order for us to come up with the values of a sub 1 and common ratio. We will use the principle of common ratio. So we know that x, or the second term divided by the first term, is equal to the third term divided by the second term. So we'll just use this to solve for the values of x. So in this case, we'll do cross multiplication in order for us to eliminate fractions. So if we multiply x to x, we get x squared. And if we multiply this, we will get a quadratic trinomial. So x multiplied by x is x squared. So this will be on the other side of the equal sign. Then x minus 1 multiplied by x plus 2. That is x minus 1 multiplied by x plus 2. So we will solve this. If you could still remember your FOIL, let's do the first. X times x is x squared. X times 2 is positive 2x. Then negative 1 times x is negative x. Negative 1 times 2 is negative 2. we will be having, wait, let's combine like terms. So we have x squared plus x, these are like terms, plus x minus 2. So this will be the other part of the equation. X squared minus x minus 2. Now having that equation, let's try to simplify it by eliminating x squared on both sides. Let's subtract x squared on both sides so that we could cancel these. And for that, we'll be having the equation 0 is equal to x minus 2. After which, let's add 2 on both sides so that we could single out x. So now, we have the value of x as x is equal to 2. Now let's substitute x here. So 2 minus 1 is equal to 1. So our first term would be 1. Then this is x, this is 2. Then this is 2 plus 2 equals 4. So we have this sequence. So that is 1, 2, and 4. We could easily see that our first term is 1, the number of terms is 6, and the common ratio is 2. So let's solve this using this formula. 2 raised to 6 is 64, minus 1 is 63, divided by 1 is 63. So the sum of the first 6 terms is 63. Now, another variety of questions is this. The sum of the first 6 terms of a geometric sequence is 84, and its common ratio is negative 2. Find the first term. If you're going to study the formula, we can see that the value of our n is 6, and 84 is the sum of the first 6 terms, and 2 will be our common ratio. We need to find a sub 1. So let's now write all the things that are given. So that's our given. Then all we need to do is to substitute that on the formula, leaving a sub 1 as our variable, our missing variable. So let's solve for the value. Let's simplify the equation. So we have negative 2 raised to 6 is 64 minus 1. Now 3. Let's eliminate the fraction negative 3 so that we could have a whole number on both sides and not a fraction. All we need to do is to multiply both sides by negative 3 so we could cancel out this negative 3. And we'll be having this kind of equation. Now simplify this by multiplying negative 2 to 84 and subtracting 1 from 64. And we will have this equation. Now we need to single out a sub 1 because we need to find the value of it. So all we need to do is to divide both sides by 63 to cancel out 63 on the right side of the equation, and we'll get the value of a sub 1 as negative 4. So the first term for this equation is negative 4. Let's go to our last example. Our last example is this. What is the minimum number of terms of a sequence 2, 4, 8 that must be added so the sum must be greater than 500? So meaning, we need to find the minimum number of n, so that the sum of this sequence should be greater than 100. Again, the minimum, meaning the lowest number of n, the lowest number of term. Now, if we could write our given, we could say that our a sub 1 is 2. The number of the common ratio is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. And n, we don't have the value of n yet. So this is an error. So I will just erase this. So the value of n is unknown. And we only need to substitute the formula. Again, the condition is this. The value of this should be greater than 100, greater than 500. So we'll use greater than sign. Okay, so we'll use this sign. So again, let's simplify it by subtracting 1 to 2 at the denominator, and we'll get this equation, inequalities. So let's eliminate 2 so that we could single out n. Let's divide both sides by 2. That is 250. Now let's add 1 on both sides. So we could eliminate this one on this side of inequalities. So we have 251 raised to 2n. Now all you need to do here is to guess a value by trial and error on what number or what is the lowest number we could possibly put to n in order for us to solve for the in order for us to satisfy these inequalities. For example, if we try 2 raised to 6, we could get 2 times 2 times 2. 2 times 2 is 4, 8, 16, 32, and 64. So this is 64. So this is not greater than 251. So let's try 2 raised to 7. 2 raised to 7 is 128. Again, 128 is not greater than 251. So let's try 2 raised to 8. 2 raised to 8 is 256. And 256 is greater than here. So this is the lowest possible number of n, or the minimum number of turns we should get. So that is n is equal to 8. Thank you everyone for watching this video tutorial. Hope you learned something today and see you on the next video. Bye bye.